In this video, we will see dry run of the code. So let's do a quick dry run of our this sample input. So what I will do, I will take a reverse with value 0. So I am taking rev, that is 0, right? And this is my n, basically 1011. And what I will do, I will first I will simply start a loop that will run for 32 times. So this is 4, so it will run for 4 times. Okay. So reverse will be first right shift with 1. So if I right shift this 0, so sorry, this is left shift. If I do reverse left shift, it will add basically one more 0 into it. Okay. And then I will take a bit that will be end and 1. So 1 0 1 0 1 1, and if I am taking 1 with end, it will give me 1 as an answer, right? Then what I will do, I will simply take an OR with my reverse. So reverse, then this is my bit. I will take the OR. So 0 0 with 1 or will give me 0 0, right? And now the answer will be remain same 0, and after this I will take a right shift of my n, and my right shift will be, it won't be 0, sorry, 0 1. I am doing or remember, or it will make it 1, it will make it 0. So now the answer is updated to 0 1. After this, once this, I will do the right shift. So this is right shift and my answer will become 101. Again, what I will do, I will simply add a space in my reverse. So I will add a space like doing a left shift. So it will become 010. After this, I will take a bit with end and 1. So I will take a bit with end and 1. So 1 and this will give me the bit 11100, right? Then what I will do, I will take reversed equals to reverse and bit. So what is reverse? 010, and I will take this one. I will take an OR 011 1 10 will be 1, and 00 will give me 0, right? So now this is my final value. My final value is 011 now. Okay. After this, I will do a right shift in my n. So if I'm doing a right shift, it will become 10 now. So now it is 10. Again, I will add a space in my reverse by doing left shift. So I will do 0110. And once I have done 0110, I will calculate the bit. Bit will be 1, and so it will make it 010, and 110 will make it 0, right? So now my bit is 0. Once your bit is 0, what is your reversed? 0110, right? Reversed. I will take an or, this is or. So I will take or with 0, basically all these value will be 0. So 000 0111 101, and this will be 0. So it will be remain as it is, right? Again, after this, I will do a right shift. So I will do a right shift. Now my value is 1, and if I am taking 1 with end, it will give me the bit that is 1. Again, what I will do, I am having 0110. I will add a space, basically reversed, right? And I will add 1. So I will add 1, and I am taking OR. So it will become 10110, right? And after this, again, what I will do, I will do a right shift of my n. So a right shift of my n will give me 0, basically. Now it's dead, right? Now it's done. So now there is basically I have done 4 times. So 4 times it is done. And I will return with my unsigned value. Basically, unsigned values means if there is a sign, I will simply return it unsigned. So here it is not signed, right? And 0110 can be written as basically, now the final is 01101, right? And basically you can read it like 1101, and that is the output, and this was the input 1011, and this is now reversed. Yes, and it is running for 32 times, only 32 times. That means it is constant. So the time complexity here will be big O of 1 constant, and space complexity will be big O of 1, right? The 30 integers will be 32-bit mostly. So that's why it is constant here, right? It is not depending on n. So yeah, that's all from my side. Thank you. And yeah, see you in the next video.